arrive. The world is teeming with innovation as new business models reinvent every industry. Inside Analysis is your source of information and insight about how to make the most of this exciting new era. Learn more. The information economy has arrived. The world is teeming with innovation as new business model. Eric Kavanagh.
All right, folks, hello and welcome back to the only coast-to-coast radio show that's all about the information economy. And now, of course, we're part of a TV show called Future Proof. It's Inside Analysis. Yours truly, Eric Kavanagh, is here with an all-star panel. We've got Steve Sarsfield from OpenText, Vertica on the line, and my good buddy Eugene Burke from Digital Strategies Group. We're going to talk about data mesh versus data fabric. Cut from the same cloth? Short answer is yes. So for our broad listening audience out there on the radio, data fabric, data mesh, these are relatively new concepts, and really they're sort of extrapolations of the database. We all know a database runs basically every application that there is out there. Databases have been around for decades now. I mean, really for probably 60 years, if you go all the way back, maybe close to 70 years. We've had database technology, and there have been tremendous advances in the database space, especially over the 10, 12 years leading up till today. So I remember when the Hadoop thing came around. So some of you may know there's a concept, a construct called Hadoop. And basically that was how Yahoo would index the web. And then there was open sourced, and a number of companies jumped on it, like Cloudera and Hortonworks. A company called MapR jumped on it. MapR got absorbed by the Borg. I think it was HP a number of years ago. Cloudera is still around, but they absorbed Hortonworks, which was odd because they were staunch, nasty competitors. And then they sort of merged. They're doing some interesting things still, but that wasn't the beginning of the database explosion, because before that, you had some other things happening, right? You've got MySQL as a database, you've got MongoDB, you've got Couchbase, you've got all these different open source databases. You have cloud databases now. Amazon has their own, you have DynamoDB. There are all these different databases. Well, on our show today, we have Steve from a company called Vertica. Well, the product called Vertica, it's now part of OpenText. I remember interviewing Dr. Michael Stonebreaker back in 2005, I believe it was, when he was just rolling out Vertica. And the reason they have that name Vertica is because it's vertical for column orientation. So a lot of people know if you go into Excel, you look at a spreadsheet, you have rows and columns. Well, rows typically contain lots of different types of data: first name, last name, phone number, email address, all this kind of fun stuff, notes. That's all in a record. That's one record. And then the columns tend to be the same, or they should be the same, of first names, last names, phone numbers, etc. One reason why that's important is because compression is easier on a column. And so Vertica was one of the first major column-oriented databases. It wasn't the first, but it was one of the first. There was Sybase IQ was one before that years ago. It was one of the first to say, you know what? People want to do analytics. People want to do analysis. Compression is a big part of that. And being able to rapidly slice and dice information is a big part of analytics. That's what we need to be able to do. So Michael Stonebreaker, who invented the modern database, by the way, if you look this guy up, he's amazing. Way back at MIT, like I think 50 odd years ago, he came up with the Postgres and the Ingress, which were database architectures that have now been used by tons of different companies. Well, I'm telling you this backstory just to help you understand how we got here. And what's fascinating is this data fabric stuff came really after the Hadoop movement. People started thinking, all right, we have these incredibly topographically challenging environments. How are we going to be able to provision across multinational corporations with many, many different users, sometimes tens of thousands of people? You'll learn in the database world, concurrency is a real issue. And being able to serve many concurrent users is a real issue, because it's like having 10,000 people come into your boutique shop someday. Well, you can't even fit them all in there. This is what happens with concurrency. You have to purposely design your architecture to handle that kind of stuff. And as my buddy Mark Madsen, who's an analyst again these days, once told me, he said it takes 10 years to find the edge case for a database that will crash it. 10 years, like after you're in production, before you finally figure out what is going to throw it off. All right. This is how complex databases are. So data fabric is even more complicated than that. I mean, quite frankly, it really is a whole array of data pipelines and triggers and monitors and sensors. Now we have data observability these days, which is all about watching for upstream changes in data. Did a field change? Is there a new column in this database? Did we not get the data? Well, these kinds of early indicators are very useful for data engineering teams and for analysts, because hitherto you'd show up and start doing your query and you just didn't get the data that you wanted. Well, what the heck happened? I don't know. Let's look into it. Like raise a ticket with IT and wait a couple of weeks. Well, those days have to be gone, folks. And data fabric is designed to be able to solve for that. And then data mesh, as I suggested, well, it's a fascinating concept. Exactly what it is, I don't know. We're going to find out. But I think I've been talking for a while now, so I'm going to go ahead and pipe down and throw it over to Steve Sarsfield from OpenText Vertica. Steve, you've been around maybe almost as long as I have, or about as long as I have. So you've seen this whole evolution, and it's kind of amazing. It's kind of bewildering, but I do feel like we're getting to a place now where, at least to a certain extent, the nuts and bolts of the data administration don't have to concern the analysts and the end users who just want to have fun with the data. What do you think?
Yeah, absolutely. It's funny. I think over the years, what has happened is the data center of gravity has changed quite a bit, right? So it used to be that the data warehouse was the center of gravity, but we can't do that anymore, right? We can't just continually move all the data in the data warehouse. So we have things like data lakes, and we have object stores that we can store our data in. But the center of gravity has changed because the volume of data is getting so much greater, and we can't possibly load that in. The number of people who want access to analytics has changed. And so we have different challenges now. We have big challenges that we can have. And so really what data fabric and data mesh really represent is that change in gravity where the data sits, whether it's in locally object store, on the cloud, various places. I think it kind of represents accessing and managing and using that data, not in one central place, right?
Yeah, and that's a really good point. And you bring up data lakes, and of course now we've gone from data lake to data lake house to lake house architecture, and just all this stuff. And I think the key is to remember the product, to focus from a business perspective on the data product. But I'm kind of reminded too of the NoSQL movement. So out of Hadoop, you had this sort of NoSQL, which meant not SQL, and then sometimes
Not only SQL, right?
only SQL,
Yeah,
right?
yeah.
Not only SQL. And what happened is very shortly after that, these NoSQL databases started strapping SQL engines on top of them. Because guess what? SQL is a standard. That's the structured query language, for those who don't know, SQL. It's a standard. And so you need that stuff. But I remember when the data lake craze came about, I started wondering to myself, are we making some of the same mistakes again that we made last time, where you just throw a bunch of stuff out there and then, okay, you hope to be able to find it, and people talk about the data swamp and things of this nature. And that's why you have people saying now lake house architecture. They're coming up with more clever ways to be able to get access to it. But that's really the bottom line, is access path and efficiency, right? Whatever your information architecture is, the key is you want to optimize the access path for the important users, and you want to be efficient and durable and secure and all that other stuff, right, Steve?
Yeah, I think we don't really have an ETL problem or ELT problem anymore, right? We're not trying to move the data around. What we're trying to do is access it in place. You're absolutely right about that, Eric. And so, we need to do some things in order to access in place. It could be data mesh or data fabric. And with a data mesh, we want to make sure that we have access to the metadata, so we can access that data on top of the data and then perform our analysis. With a data fabric, that metadata may not exist, right? So we may have to create a semantic layer, our own semantic layer, using a graph or some other technology. And so again, it's about accessing the data without having to move it into a single consolidated data warehouse.
Yeah, that's a really good point. And the metadata, so I talked about that in the semantics and data catalogs and some of these other things. They are all there to help us make sense of the data. And the other interesting development here from a business analyst perspective is that In the data warehousing world, we stripped out all the context to be able to get it through thin pipes to slow processors and be able to slice and dice the data. Well, you don't have to do a lot of that stuff anymore. I mean, I
Right.
do remember the schema on read concept coming out of the
Mm.
data lake. And even that's a bit challenging, right? Because it's going to slow the process down a little bit. You have to make sure you get that correct. But the general thrust I'm throwing out here is that you don't necessarily need to strip out so much context, read metadata anymore to be able to facilitate use down the road, right, Steve?
Yeah, that's absolutely true. I think that that metadata, that context is super important for the organization. It kind of describes how you use the data and what you want to do with the data. And so stripping that out can be, detrimental to whatever you want to accomplish in terms of business, right? We do these things because we want to understand our business better. We want to drive three areas. Area one is we want to make sure that we can drive additional revenue within the organization. We want to make sure that we're super efficient and using only the servers that we need to have and only the processes that we need to do. And we want to make sure that we're compliant. So if someone asks us for a report, we should be able to go out to those data sources and very easily get access to that. And so, having that metadata, having that sort of whatever it is, fabric or mesh or whatever, to allow us to access those data sources and perform those three things, I think is super crucial.
Yeah, we have got a couple of good questions from our studio audience, by the way. So I'm just going to throw this one out there. One of our attendees is writing, so does that mean that users would access the data at the source? That is usually not a good idea because it could put too much pressure on source databases, even with data mesh fabric. Don't we need to move the data to some central location for analytics access? And this is a good question, but I will say you are starting to see a greater focus on federated data access and leaving the data where it sits just to be able to touch it as needed. But there is a point about overburdening source systems. That's why we came up with these things in the first place, right? We realized that SAP ERP was not easy to query. And so we pulled data out of that, put it into the warehouse. But so what do you think about that? There is some concern, but I think the processes are getting more and more elegant and efficient at being able to do that. What do you think, Steve?
Yeah, it's a case by case basis. I know for Vertica, what we do is we do have data virtualization. So if you're, for example, you wanted to run a report and do a join against a table that's sitting in Oracle, that's pretty easy for us to do. And a lot of other databases have that too. So being able to go out and access that third party is key. It will tax the third party system though. And so what I see a lot of companies doing, if they're concerned about that, is they're leveraging object stores these days. So they're taking a lot of their data and just dumping it into an object store. That provides you with some pretty interesting capabilities. So a lot of the databases, including Vertica, has this whole concept of separation of compute and storage. So I have my data, it's sitting in a separate storage object store. I want to do some data loading. I spin up 3 nodes, I do data loading. I want marketing to run reports. I spin up 3 nodes, it does the reports. I want various, my dashboards throwing really fast. I spin up 5 nodes for the CEO and I run the reports. They're all operating on that same data, but we're able to access that through one location, through one engine. And we see that happening a lot in the market. It's happening within, within our customer base. And it's a kind of a new way of doing an architecture, is that whole separation of compute and storage.
Yeah, and these are all deep architectural determinations that get made.
Yeah.
And kind of where I was going with that comment about large language models is I don't really understand how they work, but what I do know is they can get around all kinds of these issues because you're dealing like with a multidimensional, remember MOLAP, right? Multidimensional online analytical processing, the MicroStrategy folks. You want multiple different dimensions, but these large language models have like 3.1 billion vertices or something. And there are lots of different ways you can slice and dice stuff. But again, we don't know about the veracity. We don't know about the clarity. We're not sure. And of course, with something like a data warehouse, you want to be really gosh darn sure about what you're doing, right?
Yeah, we want to know, what the most current information is, what the most trusted information is, and we want to be able to use that. And so, to some extent, MDM used to help us with that. We used to take all the data and create an MDM system around that. I think this is the next evolution of ETL. It's the next evolution of MDM. And because we have such large volumes and everyone wants access to the data mesh, data fabric is the next thing, is the next evolution of that.
Yeah, and so you have some of those principles baked in, right? I mean, I think that's the key, is that we've learned over the years. I remember asking myself a rhetorical question, is MDM the next SOA? If you think about service-oriented architecture, we had fine-grained services and coarse-grained services, right? And even though no one really talks about SOA anymore, I think what happened is the principles of service-oriented architecture kind of got baked into how we do cloud. And now that's just the norm. But real quick, what do you think about that, Steve?
Yeah, I think you're right. I think it is, the basic way that we do cloud. But I can't tell you how many customers I've talked to that have, like a pub subsystem too, where they're publishing data and subscribing to data via Kafka, or some of the open source tools that are available for that. So, yeah, there is, this concept of a data bus that I think a lot of companies deal with, including Kafka, that kind of help that.
Yeah, it's funny, going down memory lane again. I worked for Damon Consulting back in 2001. That's when I got into this whole space. And Michael Haston, super smart guy, consultant, has the same birthday as me. We were excited about that. He would talk about what he called an enterprise backplane. And what we was talking about is what you just mentioned, this bus. Basically, it's a staging area of data. And I meant to mention this in my opening remarks as well, that intelligent caching is older than the hills. I mean, it's something we came up with a long time ago, and it's a very useful construct for being able to facilitate access to often used data. Right now, how you manage that, how you construct that matters a lot, and will have a big impact on whether or not it works. But it's not a new concept, right? I mean, caches are a huge part of data virtualization, for example, now a big part of data fabric. That's what I was talking about, the pre-processing stuff. And, the beautiful thing is machines, unless you turn them off, they don't sleep. And machine learning, unless you turn it off, is just learning and learning and learning. They're just kind of crawling around looking for patterns. And we humans are pretty darn predictable if you get right down to it. So if you do have a machine learning layer and it's monitoring usage of data, it's going to know when the peaks and valleys are. And to your point earlier, it can spin up 3 nodes or spin up 4 nodes or spin up 2 nodes or whatever the case may be. Not that you're never going to have a hiccup again. There will always be hiccups. There will always be downtimes and things of this nature. But the point is, we're getting really close. And I think that's the key with data fabric, at least, is it's trying to be as prepared as it can be for whatever data usage you're going to need in the next hour, the next day, whatever the case may be. Well, don't touch that dial, folks. We'll be right back on a fantastic episode of DM Radio.
Welcome back to Inside Analysis. Here's your host, Eric Kavanagh.
All right, folks, back here on Inside Analysis, part of the DM Radio Broadcasting Network. We're talking to Steve Sarsfield of OpenText Vertica and Eugene Burke from Digital Strategies Group. Eugene, you heard us ranting and raving about data fabric versus data mesh in the opening. And we had a great question around logical data models and where this is all going. I mean, when I think about these large language models, again, they have absorbed far more than just text. They have absorbed concepts, they have absorbed formulae, whole spreadsheets. One of my buddies was saying, he goes, I just go to these things to get the numbers of things because that was absorbed as well. Now, again, you do have this whole issue of moorings and anchors of truth, as some people call these things, and you have to worry about all that. But what's your take on the data mesh versus data fabric religious war, or is it that big of a deal at all?
So Steve, I guess I would have a 2-part question to get us started on this segment. Are data fabric and data mesh twin sons of different mothers? Are they destined to fight? Or do they have different objectives and different mountains to conquer? And how do they relate to LLMs and this kind of adoption of a completely different paradigm for enterprise ask and answer computing?
I can answer that if you want. You know, I kind of look at data mesh and data fabric as I look at the origin story. You know, every superhero has an origin story.
Right.
I think data fabric and data mesh have different origin stories. So in the case of data fabric, the origin story has a lot to do with graph databases. You know, graph databases, to some extent, they are a solution looking for a problem. To some extent, I won't want to. I don't want to completely paint them like that, but you know, the problem that they solve, the one problem that they really solve, is that if you have disparate data, and that data is sparse, and that data is it doesn't have any metadata attached to it, it's sort of like an unknown. Graph databases do a really good job of building linkages between the data. Data that's sitting in different files, data that's sitting in different columns and rows. And so graph databases do a really good job at that. Thus, data fabric. Eric mentioned the Hadoop model, and I think the origin story of data mesh is Hadoop. You know, we have data that's kind of sitting in there in the data lake. We want to have access to it. We want to make sure we know probably that the metadata is accurate, and we know that maybe our company grew through acquisition. So I've got data warehouses that have multiple data warehouses in our organization. I've got a data lake in our organization, but the metadata associated with that is probably pretty good, and we can sort of kind of trust it. That's data mesh, and putting all of that data together is kind of where that comes from. So when I look at data fabric and I look at data mesh, I look at those origin stories, and it doesn't really answer though which one I should use. And so, you know, if you kind of turn that around and you are a pharmaceutical company and you have a lot of disparate data, and the data is a little bit messy and it's a little bit sparse, maybe the thing to do is to set up a semantic layer, access that, and use a data fabric. If you're a company that has grown through acquisition, you've got multiple data warehouses, a CRM system, an ERP system, but guess what? The data is pretty good, pretty fit for use. Maybe data mesh is the solution. And I think that's the big difference in my head of what the differences are between those solutions. I don't know, Eugene, you want to comment on that?
Sure. I guess the follow on is,
Yeah.
do you agree with some people's assessment that the data fabric is more IT driven and a data mesh is more business pull or business driven and organized around the business typology or topography? So, and what mesh is trying to solve is to put the business back in the data driver's seat.
Yeah, I think that's true. And you know, one of the reasons for that, again, is the introduction of a graph database and a semantic layer, right? That's a pretty tough thing to do. It requires a specialized set of knowledge that not a lot of people have. Only a handful of people. And I'm trying to understand what Sparkle and Cipher is, and trying to understand basically what a triple is versus, you know, a standard column and row. That requires specialized knowledge that we just don't have normally in the normal database world. So it is IT driven. It usually has a component of services and technology that are bound together that kind of work together to create that semantic layer. With data mesh, you know, we can almost pull that off if we have a good understanding of metadata and you know, how to manage all of those, and data virtualization and some of the other tools that you might use for a data mesh. Yeah, that's you know, that's more of a business initiative.
Yeah,
That's my opinion. You guys comment like that. That's how I see it though.
Yeah, I also have had difficulty wrapping my head around tuples, right? And I remember when the semantic web was going to solve all the world's problems, and it never really kind of got there. Now, there are semantic layers that you can use for a database, and that's a very useful thing. It's very similar to data catalogs, right? I mean, a data catalog is there to capture the meaning of things and to enable business people to connect dots in their systems, basically, right? I mean, that's what a data catalog is supposed to do. But again, these things are all it's just interesting how they're all sort of moving forward at their own pace. Although I'd never heard before until now. So thank you that the origin story of data mesh was Hadoop. I did not know that.
Listen, it may be wrong about that. All of these technologies, though, you know, they kind of rely on multiple technologies, right? It's the coming together of multiple technologies. So we have databases, and databases that used to run data warehouses are having capabilities around data mesh, right? They're able to go and access data that's outside of them and perform analysis on them like they couldn't ever before. And we have query engines, you know, Presto and Trino and some of those technologies. They can access data that's sitting in a data lake that doesn't have any metadata, it's not sitting in a database. Visualization tools, graph databases, data virtualization, data catalog. So a lot of those things are coming together as technologies to form data mesh, data fabric.
Yeah, that's a really good way to put it. A data fabric, I think, is the amalgam of all these different things.
Yeah.
And it is designed to be an efficient and thoroughly capable data foundation to handle whatever data uses the business may have, which is interesting too, because it's almost like we're moving in the direction of so-called HTAP, right? Hybrid transactional analytical processing, which always made me kind of wonder. There was this approach where a query would come in and you'd have sort of a sniffer there waiting. It's like, okay, is this an analytical query or an operational query? And if it's operational, okay, I'll go this way. If it's analytical, I'll go that way. Yeah, I wonder about that. Anytime you have these sort of if-then statements at the foundation of a database technology, well, that's going to affect performance, right? I mean, all this, when you get right down to it, has to do with performance. Can this thing perform the tasks I want it to perform quickly enough, efficiently enough, and accurately enough? And, you know, that's where I see tremendous pressure from these LLMs on basically everything that's in the data stack, everything that's in the information stack, because, you know, the key is to have your embedding strategy and to know, and that gets back to your point, Steve, from earlier in the show, that you as an organization, you need to start getting your data prepared for these large language models and make sure that it's trusted, make sure that it's governed, understand your processes. And one of the things that you can use to do that is a large language model, because they're actually pretty good at being able to ascertain and then articulate specific processes that you need to go to. You know, it's really interesting. I was talking to Steve Lucas, the CEO of Boomi, former president of SAP Americas. He was over at Marketo for a while. He was saying when they got in there, he started looking at what they were seeing inside their own systems, and he asked it, show me all the different versions of order to cash that we have. It was like, okay, just started. He's like, holy Christmas.
Yeah.
Wow. So we're just now scratching the surface. Now, it doesn't mean all this other stuff is going to go away, at least not right away. But it does mean that you have to get your data ready. And that means quality checks. That means lineage checks, things of that nature. What else would you suggest, Steve, and then maybe Eugene, from your experience? How can organizations get ready for that? How can you prepare your data for large language models? First, Steve.
I mean, a big one for me is access and security, right? That is a huge one. A lot of companies have PII that's sitting out in a data storage somewhere. It may be encrypted, it may not be. How do you identify that PII and make sure that you're not exposed as a company to you know, all of the potential fines that you could get around that? That is a regulatory mess that could, you know, you want to make sure that that problem is solved. We have some technologies at OpenText that allow you to actually go and take a look at even free-form text, even video and audio, and allow you to access that and take a look and make sure that there's no PII there, so that you know, you're not vulnerable to lawsuits and stuff. So security, access, encryption, that's a real key one for, you know, making sure that your data is in order for the next generation.
Yeah.
Eugene, that's one. I can probably go on, but Eugene,
So there are few things like an LLM for exposing flaws in your data. And exposing one of the flaws would be security holes. So to your point, if you have PHI or PII and the LLM has a way to find it, it will find it, right? Because that's what it's built to do. And so now is the time to understand your IAM architecture and to make sure that if you're going to use a large language model for customer service, patient service, provider service, that you really understand the pathways for accessing your highly sensitive data. And because you don't want to have an audit come up to say, okay, here's violation, or God forbid a breach, right? Because you didn't adequately think through your architecture.
Yeah.
So that's a technical component. There's also sort of like the operational components of it, right? When data governance, we used to talk about people, processes, and technology. And so the people and the processes are also something you need to look at. How is data handled? Is data copied? Regarding processes, and then people who has access to it. How are they handling it, and so on. So again, there is a component of data governance to data mesh and data fabric.
So the mixture of a Wild West data culture and LLMs is quite potentially dangerous.
Yeah, that is true. The other cool thing here, and some of the cooler technologies I've come across, have this capacity to scan your environment. Some of the data catalogs have this capacity. Very, very useful stuff. There's a company, it's really more in the security and governance space, Extra Hop. I haven't taken a briefing from them in a long time, but what I loved about them is that they will scan, they basically just siphon off your network traffic and then create a digital twin of your entire information landscape to show you every database, every application, anything that's touching it, you see an object for that. And that's the kind of tech that you can use. And of course, LLMs, I mean, like we said before, if you point one at your information architecture, it's going to start sucking that stuff up. And if you weren't careful about what went in there, it's going to be very difficult to get it out. It's like unlearning things. It's hard to unlearn something, and I often use the analogy of raising children to explain how to train your large language model. If you've got a 2-year-old, you don't want to let her hang out with a bunch of gangsters in the hood for a while, because they're going to absorb all this information, these behavioral patterns. So you have to be careful about how you train, what access you give to these models, just as you do raising your child, because all of a sudden your kid will be reflecting things back to you that you don't like. And you're like, well, where did that come from? Well, I don't know. Where did you allow this child to go? What did you share with this child? Well, just funny story. One of our babysitters watched with our, I guess, 3-year-old, the Chucky movie, like the Chucky, the little killer. And we're just like, all right, why did you do that? Now our kid loves these really dark, disturbing movies. We're like, all right, I don't know if that was the best move on our part, but once it's in there, you're not going to get it back out, right? Unless you like unplug the whole thing and start from scratch. That's not going to be fun. That's not going to be fun. And I think that this is a major trend line that we are going to see here over the next number of years. It's going to be very interesting, but this is what I see. We'll pick this up after the break and see what Steve and Eugene think about this. But I think most large organizations, even mid and even small companies, are going to pick their poison. They're going to choose, okay, I'm going to use Bard, or I'm going to use OpenAI, or I'm going to use Anthropic. I'm sure some others will come out, and they're going to begin this process of training that large language model, that AI model, on their corporate data. Well, that process, I promise you, is a really, really important process. And I'm throwing out this concept. I'm saying it's a second chance for data. And what I mean by that is, we've spent the last 40 odd years doing all sorts of things to move data, cleanse data, enrich data, load data, access, analyze, parse, all this stuff to get some value from it. And now it's a big reset. We're going to hit the reset button on data, and it's called the large language model. But folks, don't touch that. I'll be right back. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanagh.
All right, folks, welcome back here to Inside Analysis, part of the DM Radio Broadcasting Network. Your host here, Eric Kavanagh, with Steve Sarsfield of OpenText, Vertica, and Eugene Burke of Digital Strategies Group. And I wanted to throw this question at both of you. One of our attendees is talking about logical data models, right? We had logical data warehouses, which was a sort of virtual data warehouse. There are lots of different ways you could do these things. And he writes that LDMs are the semantic layer that is missing. I presently create LDMs to document primary key, alternate keys, business definitions, relationships, PII classifications, and many other things that are not in the physical implementation layer. That's a very clever way to go about things. And I think that you could even load some of those as embeddings into your large language model. But these are really interesting observations. So I'll throw it over to Steve first. I've got this concept that these large language models represent a second chance for data. What do you think about all that?
Wow. Yeah, I think that's true. It's interesting how over the years we have these different ways of accessing and managing data. I think you're right that large language models will be the way to create semantic models and access data of the future. So yeah, I'm not sure I have any more to add to that. That's a great way to access data.
Yeah, I'll throw it over to Eugene. What do you think? Because it's not like, from my perspective, it's yes. First of all, these are text generators. That's really what they're designed to do. Of course, they're also art generators and different things like that. But when I'm thinking about this, what I'm really thinking of in the darkest corners of my mind here are that, a multi-dimensional structure that has like 4 or 5 dimensions that can be pretty complex. These things have billions of vertices, which means the complexity is through the roof. It's just all over the darn place. And that allows you, and I'll throw one last little story, Eugene, and then you can comment on it. I remember watching Carl Sagan when I was like 10 or 11 on his show, The Cosmos, and it's like billions and billions of stars. And he gave this presentation where he had a table and he had a bunch of little pieces of paper and like squares and circles on the table. And he goes, this is a 2-dimensional world, and all these little creatures are in their 2-dimensional world. Well, imagine if someone could come along and pick up one of these 2-dimensional creatures and lift it into the air. And now all of a sudden it can see all the 2-dimensional creatures floating around. What kind of impact that would have on your thought processes and on your ability to extrapolate and to come up with new ideas. Now, I mean, I can see that like it was yesterday, and that was like 42 years ago that I saw this, but it was just such an excellent way of articulating the power of perception and of perspective. But what do you think about all that, Eugene? Is it a second chance for data?
It is. And so back to the analogy or the story of feeding something that a 3-year-old ought not to have. If you're trying to use LLMs in a customer interaction scenario, you only get one chance to make that first impression.
Yeah.
And if the consumers or customers lose trust in the implementation of a large language model, it's going to be very, very difficult to get it back. If you don't have the guardrails to say, oh, it's still learning. Well, most people understand that. But if it's an all large language model doing bank customer service, provider customer service, it needs to be fed the good Gerber food, right? And so here's the second chance for data. So feed it only the good stuff.
Right.
And so thinking about the strategy for preparing these models, maybe don't expose it to kind of the swamp, right? Because it's going to ingest some of the swampiness. So I was reading yesterday, really incisive kind of analysis. Tech debt is one thing. Data tech debt is actually more insidious than that. Because once your business customers, your internal customers or your external customers lose trust in the data that you're showing them, the information that you're saying, this is represents the business, or this represents your customer status, and it's wrong, then you have almost no end of pulling your hair out. Because I guess the moral to that story is prepare your models very well.
Hey, just an add-on to that, it's pretty interesting. I read an article in Time magazine that talked about how ChatGPT used Kenyan workers to actually get rid of the toxicity, right? So they used workers to actually go through the data and said, is this toxic content that we're putting into ChatGPT or not, right? And that was one of the ways that they got it. So they got out of, or they didn't have too much toxic information in ChatGPT. But I think we should think about that is, how can human intelligence and AI intelligence augment each other as we're building these models?
Yeah.
So we can look to that to kind of as a test.
Yeah, that's an excellent point to make, Steve. And I think the upshot of what I'd like to share with the audience here today is that your data warehouse, your data marts, the things that you've worked very hard on need to be a crucial and foundational component of your AI model. And they should be front and center as a trusted source. That is the primary source that you want to use, is something like a data warehouse, because you have governance, because you have all this attention that's been paid to the model. And remember, like, the data of your organization reflects the organization itself. And I think we could see some really interesting things happening of dynamically generated data models that look at the data and the flow of data and go, maybe you should reconfigure your data model to better reflect this new way that things are working in your organization. I think that's coming too. There are a lot of fun things that can kind of spin out of this. But the other fun point I'd throw out here, maybe just get a comment from each of you, is I've been seeing when you connect these engines to your data sources, there are lots of cool things that you can do. And think about if you've ever done a Google search for instructions for a particular app. How can I use XYZ app? And you get something that says, okay, step 1, go to the file and click on the red button. And you go there and there's no red button. You're like, all right, what is this talking about? Because it's an old version. It's an old version of the previous app or the previous version of the app. That is a very difficult problem to solve, or at least has been historically, because you don't control Google search engines, right? You don't control that stuff. And so they're just going to find old stuff that is difficult to manage. Well, if you do this correctly, the large language model can sense, like change data capture, when something has changed, and when the source file has changed, it goes, aha, update, and just go grab that stuff dynamically. So you start thinking about, that's really powerful stuff, because when you make the change to the system of record, it's almost instantaneously reflected in the large language model that you're using to interact with the environment. But the closing thoughts from you, Steve, what do you think?
Yeah, I just one comment on that. So databases have things like indexes and materialized views, and we have something called projections, right? Projections, what they allow you to do is, based on your queries, how can I optimize the data? So that is all AI driven now for a lot of companies out there, for Vertica and for some of the other database companies that exist. So I'm watching, as an AI, I'm watching the queries that take place. And I'm saying, if I had this materialized view, or if I had index configured this way, I could switch it around and I could run that query, that query 10 times faster. Some of that functionality exists today. That's something that we're always looking to build out, for optimizing speed. So yeah, I mean, there's that component too.
Yeah, and I think that you can also, again, dynamically provision these things. So that's the other fun thing that my buddy Lou Simon was mentioning, is he's like, think about this. Historically, you had to learn to speak computer in order to talk to your computer. You had to learn the structured query language. You had to learn Python. You had to learn some language to be able to communicate with this machine. You don't have to do that anymore.
Yeah.
Now you can use natural language to communicate with these things. And I mean, I'm telling you, this prompt engineering stuff, it's taking off as well. It should. And it's going to be amazing when we hit what's called interactive AI, which I think is really the next big phase that's coming. And it's going to be wild, because if you let these intelligent bots loose on your environment, woo, we'll start.
I absolutely agree with that. I think the next big thing, the next big snowflake, the next big database, if you will, or analytics engine that comes to market that solves that problem, that says we're going to be really simple. You're going to type natural language queries, and we're not going to care at all about SQL or Sparkle or any kind of language, Cipher. We're going to answer that query based on that language that you enter in. I think the company that does that is going to succeed and be the next big thing.
Yeah, I think you're right. Well, folks, this has been an absolute blast talking to two experts, Steve Sarsfield of OpenText Vertica, look him up on LinkedIn, and Eugene Burke of Digital Strategies Group. things are changing very, very rapidly. And, one of the fun quotes I heard the other day with respect to understanding machine learning and artificial intelligence and where it's all going was learning, meaning human learning, meaning we as humans need to learn how these things work. And the way you do that is by playing with them. Send me an email, info@insideanalysis.com. You've been listening to Inside Analysis.